In this video, we'll look at question 45 from the 2017 exam. So in this question, we have a geometric progression whose first term equals 1, and the common ratio of the terms is half sine 2x for some x, so that the sum of all the terms is 4/3. And we are supposed to find such an x which will satisfy this condition in the interval from pi to 2 pi. So this is the formula for the sum of an infinite series, provided the absolute value of r is smaller than 1. If it isn't, then we'll have problems with convergence, divergence. But we don't really have to worry about that here because sine of x is always constrained, and half sine of 2x will oscillate between -1/2 and +1/2. And just to clarify, a is the first term of the geometric series, and r is the common ratio of the terms. But this is the equality we get if we substitute into this formula our values for s infinity, r, and a. And as you can see, that's an equation in only x, so we'll be able to isolate sine 2x and then look at the possible values in the given interval. So here I multiplied the whole equation by the denominator of the fraction on the right-hand side and by 3. This is what I got. And that's the same as sine 2x equals 1/2. To help us find the roots, I plotted the function sine of 2x and 1/2. So one thing we know is that sine of pi over 6 equals 1/2. However, remember that our function is sine of 2x. So in order for the argument to be pi over 6, we need x to be pi over 12. And by the symmetry along this line here, we see that the other solution will be pi over 2 minus pi over 12, which is 5 pi over 12. In fact, we are interested in these two values in this interval, but I just did it in the interval from 0 to pi because everything is easier for me to picture closer to the y-axis. But this whole part of the graph is just shifted to the right, so we know that the x-coordinates of these 2 points will be the same as these ones, just with pi added to them. So this is all moved by pi, which gives us for the 2 coordinates 13 pi over 2 and 17 pi over 2. In other words, 13 pi over 2 and 17 pi over 2 are the two values in the interval from pi to 2 pi which solve this equation. And remember that this equation was derived from the condition on the geometric progression which was given in the original problem. So these are the two x values we're interested in, and indeed that was option A in the exam.